Hai and Assalamualaikum. My name is Saidatul Nadhirah binti Muhammad Sallehuddin. I am with my friends UMMI KHALIDAH binti Ali, NURUL NAZIRAH binti HALMI and PUTERI NURFATIN ATIQAH binti FAUZI. My lecturer name is Dr. Mat Ashadi bin Mat Johari. Today I'm going to do some assignments with my friends, which is understanding RF communication in television systems in course BERT3363 Telecommunications Electronics.
Task 1. Theoretical background. Radio waves are used in radio frequency communication, a form of wireless communication to send and receive data. Frequency range 3 kHz to 300 GHz. Technology are using RF satellite communication, TV signal, Wi-Fi, mobile phone, Bluetooth, radio broadcasting. Transmission process. Transmitter convert data, voice, video, digital into an electrical signal. Modulation. The signal is needed to a radio frequency carrier wave. Antenna send a modulated signal as an electronic magnetic wave. Reception process. Receive detect the radio wave. Demodulation extract the original data, voice and video. Common modulation technique. Amplitude modulation, frequency modulation, pulse modulation. Benefits of RF communication: no physical wire needed, flexible and compatible with the various devices used for long distance transmission. And lastly, challenge: physical barrier with the interference can affect signal. Next, the role of RF circuit in television broadcasting and reception. RF circuit in television broadcasting. 1. Signal conversion. Convert television content, audio and video into electrical signal. 2. Modulation. Signal are modulated onto an RF carrier wave based on the broadcasting standard. Analog broadcasting amplitude modulation, AM for audio. Frequency modulation, FM for video. Digital broadcasting use advanced technique like QAM or OFDM. Next, RF oscillator generate a steady RF carry wave based on the station assigned frequency. Number 4, amplification. RF amplify boosts the modulated signal for a long distance transmission. Number 5, transmission. The amplifier signal is sent via an antenna into a atmosphere as an electronic magnetic wave. And next, RF circuit in television reception. 1. Antenna reception. TV antenna receive broadcasting RF signal as electronic magnetic wave. Number 2, signal demolition. RF circuit in the TV receive extract audio and video from the RF signal for display.
For task 2, we build two block diagrams of RF transmitter and RF receiver in television signal. For first block, diagram is RF transmitter that used in television signal. The diagram illustrates the basic component of a simple communication system that focus on the signal transmission process. It is begin with an audio signal source, which is generate the sound and convert it into an electrical signal or information to be transmitted. This signal is sent to the oscillator, which is produce a high frequency carrier signal for transmitting information. Oscillator also can exchange RF signal that it allow the transmission of information over long distance by modulate it with desired data. The carrier signal is then combined with the audio signal in the modulation stage. modulate that allow low frequency information to be carried on high frequency carrier signal. This modulate signal before was fed into the transmission stage where it is amplified for broadcasting. Transmission take the modulated RF signal and send it to the antenna. After that, the power supply provide energy to the system component to ensure proper function. It also guarantees that active elements such as transistor or integrated circuit that function at their ideal voltage and current. Finally, the amplified signal is transmitted into the air via the antenna that is essential for enabling wireless communication. Antenna also is to transform the electrical signal produced the transmitter into electromagnetic signal. This process enables the transmission of audio information over the distance. The next diagram is illustrate the RF receiver signal process in television system. The antenna capture incoming electromagnetic signal and convert them into electrical signal. These signal are then sent to the amplifier, exchanging the weak signal received by the antenna and boost their strength to ensure they can be proceed effectively. The amplified signal is passed to the demulator, where the demulator retrieving the original information such as audio or data. It is extracted from the carrier signal that antenna receives. After the demulation, the signal goes through a filter to eliminate any noise or unwanted frequency, ensuring that only the desired information remain. Filter also can shape the signal, eliminate a high frequency noise or low frequency disturbance that might distort the information. Finally, the clean signal is sent to the output stage, where it is delivered in a usable format such as sound or data. For the end user, it is served as the ultimate interface between the receiver and the user provide the intended content in suitable format. This process enables the RF receiver and reproduction of transmitted information.
Hi, I'm doing for task 3, which is simulation. I will give 3 explanations. The first one is simulation of RF oscillator for transmitter and receiver. And the second one is modulation and demodulation for transmitter and receiver. And the third is analysis result of transmitter and receiver. So for the simulation of RF oscillator transmitter, this RF transmitter circuit is designed to wirelessly transmit audio signals. The microphone captures sound wave and converts them into small electrical signals, which are then amplified by the transistor, which is BC547. The heart of the circuit is the LC oscillator, consisting of an inductor L1 and capacitors C1 and C2. This oscillator generates a high-frequency RF signal with the frequency determined by the values of the inductor and capacitors. The audio signal from the microphones is used to modulate this RF signal, combining the audio information with the carrier frequency. For transmitter modulation and demodulation, based on this circuit, modulation is present but demodulation does not occur within the circuit. This is because the circuit functions solely as a transmitter, responsible for modulating and sending the signal, while demodulation happens in a separate receiver circuit. Modulation in the circuit. Modulation occurs in the RF transmitter when the audio signal from the microphone is combined with the high-frequency carrier signal generated by the LC oscillator L1, C1, and C2. Analysis of result for transmitter is: first, carrier signal, RF oscillator output. The large sinusoidal waveform, the blue line, represents the RF signal generated by the LC oscillator. This waveform is a high-frequency carrier signal determined by the LC circuit's resonant frequency. And for receiver, simulation of RF oscillator, transistor Q1, 2 and 2222A. This is a bipolar junction transistor BJT that acts as the main amplifying element in the oscillator. It provides the necessary gain to sustain oscillations. For C1, 1 microfarad, this capacitor can be part of the feedback loop, helping to determine the frequency of oscillation. C2, 0.1 microfarad, and C3, 0.0047 microfarad. These capacitors may be used for coupling or bypassing, affecting the frequency response and stability of the oscillator. Modulation and demodulation for receiver. The circuit functions as an RF oscillator, generating a carrier wave that can be modulated to transmit information. Modulation occurs by varying the amplitude of the carrier wave based on an input signal, such as audio, allowing for amplitude modulation AM. On the receiving end, the modulation attracts the original signal using diode like D1 to rectify the modulated wave and a low-pass filter to smooth the output. And finally, for analysis result of receiver, the analysis of the circuit indicates that it operates an RF oscillator, generating a specific frequency determined by the values of the resistors and capacitors. The transistor Q1 amplifies the signal, while the feedback network composed of resistor and capacitors ensures sustained oscillations. The circuit can also support modulation by varying the amplitude of the output signal based on an input, and it can demodulate received signals using a diode and filtering components to recover the original information.
Okay, so now I will present about analysis. First, distance between transmitter and receiver. When the distance between the transmitter and receiver increase, the signal strength decrease. This attenuation occurs because electromagnetic waves spread out over a large area and face energy loss with increased strength. To solve this problem, we use a higher power transmitter to increase the effective range and ensure the circuit design could handle the increased power without distortion. Okay, next, obstacle in the transmission path. We experience optical or alignment issue between the transmitter and receiver antenna, which alter the polarization of the signal. The mismatched polarization reduces the effective receive signal strength. To fix this problem, we use a poorly polarization antenna. Next, environmental noise and interference. The noise itself do not reduce signal strength, but the high level of interference overwhelms the transmitter signal, making it appear weaker relative to the noise floor. Environmental noise such as electromagnetic interference (EMI) from other devices and overlapping frequency degrade the quality of the received signal. To fix this problem, we can enclose the circuit in a Faraday cage or use EMI shielding material to block internal electromagnetic noise. In conclusion, we now have a better understanding of the function of radio frequency communication in television systems. We have examined the foundation of contemporary broadcasting. We have also seen how crucial parts like oscillator, amplifier, and antenna cooperate to guarantee that signals are successfully sent and received. However, difficulties like distance, obstruction, and noise can erode or skew signal. So, it is not always easy, but we learn some method to solve this problem. In the end, the study has proven to us the importance of radio frequency communication in enabling to smooth transmission of audio and video in our daily life. That's all from us. Thank you.